Hey everyone, we're gonna work through the rest of our lesson that we started before about properties of logs. I'm not exactly sure what page it's on. I think it's page 236. You're looking for this screen or this title near the top, change of base. So I need you guys to write this part down. You might want to pause the video to write all this loveliness. And then I want to focus you on what we're looking for here. Change of base is a way that is a way for us to do a log that has any base and be able to do that on any calculator. You might remember I mentioned that calculators only work in log base 10, or they will also do natural logs, which are base E. So when we have a different base, like in this problem where it says A, we don't know what number it is, but some other number, we need a way to be able to still calculate that log. So here are the different ways we can rewrite it. We're going to focus on this version. Most of our stuff will be done with this one, but then we'll also come back and look at this one as well. So I'm going to jump right in because it's just a little bit easier to just go for it. But again, make sure you get those written down. So the first one, example 1, we are going to try and find or rewrite this as a change of base, which means we want it to be in either a common log or a natural log, something we can put into our calculator. So basically how it works is you just rewrite it with the base on the bottom and the other number on the top. So here's what it looks like. Log 25 and log 4. So the base becomes the of number or the regular number, and the 25 stays the regular number. And then they both now have a base 10. So you could type that into your calculator and get an answer. All right, so one more time. The base is going to stay on the bottom. So it's going to be log 2. And then the top or the numerator of this fraction that we build is log 12. So something like that. And again, you can type that into your calculator and get an answer for it. And that will work with basically any calculator. And of course, practicing one more time. This actually is asking us to evaluate it. So if I do that, I would be setting it up, first of all, with change of base. I get log 8 over log 4. And then it would be typing into your calculator, which I forgot to get my calculator ready. So let's hold the phone for a quick sec. Hold on to that, and let's grab, not that, Desmos. Desmos can help us out. All right, so I want to calculate, I believe it was log 8 divided by log 4. And it already has done it for us. It is 1.5. So again, super handy way to be able to type it in. There's Desmos. Let's see if we can get back to our screen. So that was 1.5. All right, so this one I will set it up for you, but I'm going to have you guys go ahead and do those calculations on your calculator. Again, this one would be log 0.012 in the numerator and log 5 in the denominator. One thing I do want to go back really quickly to the first one. It asked us to do it as a common log and a natural log. Most of the time, we're just going to do regular common logs, but you can do the exact same thing. Instead of doing log 25 and log 4, you could have written it as natural log 25 and natural log 4. So it's an either or situation. You can do either one. So going back to the one we did, since we did this one on Desmos, I'm going to actually exit out and go back to Desmos for a quick second because I want to show you that it works either way. That's not what I meant. Sorry. Okay, so if I jump back to Desmos real quick, then I can do natural log 8 divided by natural log 4. And there you see, it doesn't matter whether it's a regular log or a natural log, it works with either version. All right, so back to our lesson. So I would like you in your notebooks to actually calculate that out, and it will be posted on PowerSchool so you can check your work later. We're going to skip the graphing one. I will set it up for you so you can see. We'll just do it real quick. We'll just do it. We'll use Desmos to help us out. So the graphing, if I look at this as f of x is fine as a function, or I can say y, because we're going to type it into Desmos. It's a little easier. If I do change of base here, I would call this log of x plus 2 over log 3. And so I'm going to take that and I'm going to actually type that into Desmos back and forth a little bit here. X plus 2 and 3. Let's see. All right, so in my Desmos, I'm going to get rid of these. I'm going to type in y equals log of x plus 2 divided by log 3. And so there you can see a graph, which I will let you pause the video and sketch that graph into your notes. But that's basically using the change of base to create that log, again, with calculators that don't function so well with different bases. Okay, so back again to our presentation. So rewrite the expression. This one jumps around a little bit, so I'm not exactly sure where this is in your notebook, but we're going to rewrite the expression in terms of natural log 2 and natural log 3. I think in your notebook it has, we should come across some in your homework where they will give you a value for this and actually ask you to figure it out. For now, we're just going to see, is there a way I could rewrite this using some of our properties? So you may recall from before that we did some multiplication and division properties. And so if you look at this natural log 2 and natural log 3, 2 and 3, if I multiply them together, give me 6. So I'm going to actually split up my 6 and say that it is 2 times 3. Then we learned that multiplication can be split into addition. So natural log 2 and natural log 3. And there you go. We rewrote the expression in terms of natural log 2 and natural log 3. So in a similar fashion, we're going to try and rewrite this one with, again, 2s and 3s. We currently have division, so I'm going to just immediately change that to subtraction to see if that maybe helps me out. So natural log 2 minus natural log 27. So I have the 2. I just need this other one, my 27, to be a 3. So then I would ask, is there some way I could rewrite 27 so that it has a 3 involved? So there's a couple ways you could do it. You could say 9 times 3 and then split it into addition. Or you could do my favorite version. And you could say 27, hey, that's 3 cubed. And if I do 3 cubed, then I get to log. So we're going to plop that 3 in front, and we have this expression. So either way you do it, you should end up at that result. All right, so here you go, where this part of it, we have some expressions, and they give us actually values to use, and I'm going to have you guys do that in your calculator, but we'll see if we can set them up. We have 3 different ones. We can rewrite this in terms of log base b of 2, log base b of 3, or log base b of 5. So looking at my numbers in my problem, I have a 9 and a 4. So those to me look like we're probably going to be using the 2 and the 3. I'm going to once again start by using my division property. So I'm going to say log base b of 9 turns into subtraction. I'm sorry, 9 over 4 turns into the subtraction log base b of 9 minus log base b of 4. Then I still need to rewrite these so that they are 2s and 3s. So one more time, I'm going to change 9 I'm going to use my exponents here, or my powers. I'm going to say 3 squared minus log base b of 2 squared. And then I get to plug twice. So put that 2 in front. Put that 2 in front. So I have 2 log base b of 3 minus 2 log base b of 2. At this point is where you're going to substitute in. So we know that log base b of 3 up here equals 0.5646. So we're going to plug that in, replace it, and do the same thing over here for my log base 2. We know that that one is the same as 0.3526. So again, I'm going to leave that part for you guys to do with your calculators, and go ahead and check that out. I'm going to actually stop the video here just because my computer is dying, and I will actually, let's see what we have left. Nope, we're going to do the last. Yeah, we'll stop here. I will stop there, and I'll catch up the rest with you guys later.